Today's video explores the fascinating process behind building a Japanese-style yurt. The journey starts with selecting and prepping the construction site, where a carefully marked circle is laid out directly onto the lawn. At this stage, all structural accuracy depends on perfect radial alignment from the center outward. With the plan finalized, the builder proceeds to dig foundational holes in the ground. Short wooden posts and clusters of reinforcing bars are set into these holes before being encased in poured concrete. This creates a firm, elevated base that also shields the yurt from damp soil below. To enhance durability, vertical stiffeners are secured around the exterior of the laminated ring. Next, attention shifts to building the platform that will serve as the yurt's floor and main support. Each piece is shaped to nest together like pie slices in the radial floor layout. Using precise markings and a jigsaw, the maker cuts the curved sections. These contours match both the ring opening at the center and the round platform edge. For reinforcement, the subfloor is framed with 2x4 lumber configured into square box structures. Plywood is mounted over these frames, then sanded down for a smooth, unified finish. After insulating the circular floor base, the builder starts assembling the upright wall panels. These units are pre-built either on the floor surface or nearby workbenches, then carefully placed into position. Maintaining a continuous arc around the perimeter was a critical design goal. Curved upright studs, pre-shaped in the workshop, reflect this precise curvature. This craftsmanship ensures that the vertical walls stay true to the original circular foundation layout. Each panel is joined securely to the next and bolted to the platform beneath, forming a unified outer shell. In parallel, construction begins on the load-bearing support system for the compression ring. Within the gradually forming ring of wall panels, a temporary wooden support framework is built in the middle of the platform. It serves a dual purpose, providing stable support for the compression ring during rafter assembly and ensuring the correct elevation. Openings for doors and windows were pre-designed into the wall modules, measured and framed in advance for future fitting. After completing this stage, we observe the start of building and attaching the compression ring and radiating roof beams. Multiple bent strips are layered and clamped together, forming a thick, curved structural beam through lamination. An array of bar clamps is used to apply uniform pressure, showing the precision taken during this crucial step. Assembly continues as rafters are secured between the central ring and the top of the round wall structure. They are fastened using bolts or screws, with each one aligned and adjusted before being permanently set. At this point, the curved exterior walls are fully covered in waterproof sheeting, and a pre-installed door is visible, unlike typical houses that use standard rectangular fixtures. A yurt's circular and curving wall shape introduces complex design constraints for windows. Standard windows are rarely suitable due to their inflexibility and the high cost of customization. Additionally, their straight lines can clash both structurally and aesthetically with the yurt's radial rhythm. Instead, custom-made frames composed of laminated parts can be bent subtly to follow the curve of the outer wall. To finish the topmost part of the roof, where the radial beams meet around the compression ring's center. The insulation step follows the full installation of the pie-slice-shaped roof panels. Unlike regular boards, these roof segments are tapered wedges that narrow inward as they rise. Because of that, each insulation layer must be uniquely cut to fill the curved space tightly. 𝐬𝐮𝐬𝐜𝐫𝐸 incorporates fiberglass for both sealing and structural cohesion. Before dismantling internal bracing, the builder inspects the roof to ensure it holds under its own weight. After confirming its structural soundness, he carefully removes the temporary support timbers. With protective sheeting laid, roofing work continues with the application of shingles, starting from the perimeter. On a rounded roof, shingles can't be installed in the usual straight rows due to the curvature. Instead, they are fanned out or angled slightly, with each piece trimmed for precise overlapping. Simultaneously, he fabricates small overhangs above windows to divert water away from vulnerable joints. In the old-world Mongolian yurt, the exterior uses organic, breathable fabrics and natural insulators. These traditional materials provide limited insulation and depend largely on the yurt's shape and low roofline to retain warmth. Yet, they are susceptible to absorbing moisture from the environment. Though the felt can dry over time, constant dampness or rain can diminish its insulating capacity and shorten its longevity. In comparison, 𝐬𝐮𝐬𝐫𝐞's design transforms the envelope into a fully sealed, well-insulated barrier built for endurance. However, before adding insulation, the framework for the interior wall system must be assembled. Precision remains key here, as the circular perimeter and wedge-shaped floor demand careful alignment. Standard 2x4 or 2x6 lumber is used to construct the studs and headers that frame these interior partitions. These pieces are joined using nails or screws, similar to the framing approach in standard residential construction. But while the original yurts emphasized lightness and disassembly, this build aims for lasting permanence through solid wood construction. Perhaps the most significant contrast is in the way the outer shell, or building envelope, is designed. The water lines were run using PX tubing, known for its flexibility and ease of installation. To prep for the shower, blocking was added to anchor future panels, and enough space was left to accommodate hot and cold lines. Doors to the bathroom and shower areas are measured and built to match the custom openings. Lightweight, but hinges are attached to ensure the doors swing open and close without friction. The round footprint encourages a radial layout, where furniture and walls gently follow the circular form. Cabinetry is placed near the entrance area, blending into the curve while keeping the central zone unobstructed. Following this, the chimney needs careful planning and installation using heat-safe building methods. A fireproof base or tiled pad is built on top of the insulated floor to serve as a secure platform. The chimney's path is mapped out to align with the room's layout and the external curvature of the structure. Rather than exiting through the top compression ring, which has been sealed with a skylight or fiberglass dome, the flue is directed straight up through one of the curved wall panels. At this stage, absolute precision is essential, as the wall acts more like a curved shell than a flat surface. The first and arguably most important shift a woodworker must embrace is abandoning standard furniture arrangements. Rather than placing boxy pieces flat against a wall, they must be crafted to match the radial sweep of the interior. These furniture items are shaped on-site, often using scribe fitting techniques adapted from log cabin and timber frame joinery. Next, the builder constructs a mosquito-proof screen for the main entrance to keep bugs out without blocking airflow. Fiberglass mesh is chosen for the screen due to its durability and ventilation properties. It's stretched taut over the doorframe and fastened with spline gaskets, similar to the method used in traditional screen doors. Weather stripping is added to seal gaps near the floor or tight curves at the top corners, eliminating entry points for insects. The full frame is then treated with eco-friendly oil or a low-emission sealant to protect it from weathering. For the kitchen area, the countertop was made from laminated wood panels shaped and sanded to precise measurements. Beneath the stove section, reinforcement was likely added to support the load and resist heat damage. An exhaust hood is securely installed above the cooktop, with brackets fine-tuned for optimal clearance. A molded shower base was installed to act as the foundational tray for the enclosure. Thanks to the pier foundation, 𝐬𝐮𝐬𝐫𝐞 could easily access and modify plumbing from beneath the structure. With interior details wrapped up, attention now shifts to the outdoor workspace. At this stage, transforming a shipping container into a workshop proves to be a practical and efficient decision. It all begins with selecting a flat area and plotting out the container's final placement with accurate measurements. Targeted digging follows, creating holes exactly where the heaviest load-bearing parts of the container will rest. Each hole is partially backfilled with crushed stone to enhance drainage and block moisture from rising up. As the project nears completion, he begins work on the yurt's outer walls to ensure they're strong, breathable, and visually cohesive. To do this, a reinforcing mesh is installed across the full wall area. This mesh adds strength to the upcoming plaster layers and helps resist future cracking. Using a traditional hawk and trowel, he applies the first mortar layer, pressing the mesh into the fresh plaster. After curing, a smoother coat is spread with finer mortar to even out texture and cover small gaps. This step creates a level surface and sets the stage for the final wall treatment. Here, it's worth considering how these methods compare to yurt building traditions from the past. In fact, this small-scale yurt showcases an impressive blend of ancestral wisdom and modern craftsmanship. The design roots stem from the Mongolian yurt, a time-tested home tailored for quick setup and mobility. Once again, he carefully orients the wood grain, integrates hidden ventilation gaps, and matches the exterior styling with the primary yurt. Since the location lacks grid power, an off-grid energy solution is necessary for the water pump. The builder constructs a secure, ventilated enclosure to route power safely to the pump system. But the integrated design philosophy guiding every element. It represents a meaningful, technically thoughtful transformation of temporary ideas into something enduring.